Hello everyone, my name is Gregor Kandare. Welcome to the first unit of the Remain project course Remote Update of Programs and Functionalities. The title of this unit is Introduction to Programmable Logic Controllers. Let us have a look at the most important points we will address in this lecture. First, we will briefly describe the learning outcomes. Then we will talk about historical background, what kind of control system were in use before the advent of programmable logic controllers, and what had led to introduction of the programmable logic controllers. Subsequently, we will explain what PLCs are, how they operate, and how we can program them. Learning outcomes. By the end of this lesson, the learners will find out where programmable logic controller technology comes from and understand what programmable logic controllers are, how they work, and how they can be programmed. Historical background. Relay logic control is, or rather was, a traditional method used in industrial automation to control processes and machinery. It relies on the use of electromechanical relays to create circuits that perform logical operations such as switching, sequencing, timing, allowing for the control of devices such as motors, pumps, valves, etc. Key components of relay logic control are relays. Relay is an electromechanical switch that opens or closes contacts when its coil is energized or de-energized. Switches and buttons, timers and counters, wiring. Relay control circuits are roughly divided into two sections. On the left-hand side, we have the so-called input section. On the right-hand side, we have the output section. The input section receives signals from sensors, switches, or other control systems. The output section of a relay control scheme consists of relays that are activated by the input signals. The relays control devices such as motors, lights, valves, heaters, or other electrical devices. When the start button is pressed, the relay coil is energized and the contact closes. The closed contact energizes the motor. It also energizes the relay coil, so it remains energized and the contact remains closed even if the start button is released. The only way to de-energize the coil and thus open the contact is by pressing the normally closed stop button. Logical expressions in a relay control logic system can be implemented as follows. An AND logical expression is implemented with normally open contacts in series, which in this case means if the first contact is closed and the second contact is closed, only in this case the solenoid is energized. The OR expression is implemented with normally open contacts in parallel, which means here in the example, if the first contact is closed or the second contact is closed, the coil is energized. A NOT operator is implemented simply with a normally closed contact. If not activated, it energizes the coil, and if the contactor is activated, the coil would be de-energized. Let's talk about advantages and disadvantages of relay logic control systems. The first advantage is their simplicity. Such systems are easy to understand and implement. The second advantage is reliability. Electromechanical components such as relays are reliable and durable also in harsh conditions. Furthermore, no programming is required. So that means that they can be designed, such systems can be designed also by technicians without programming skills. On the other hand, the disadvantages relay logic control systems can be complex in large systems, and then they require a lot of space and maintenance effort. They are also limited in flexibility and scalability. What are programmable logic controllers? We have seen in the previous slides that relay control logic systems consist of wiring of input and output devices. We have also seen that we have issues when implementing, changing, and maintaining the wiring. So, by the end of the 1960s, some engineers had an idea. What if we built a system that would enable us to connect all input and output devices, and that such system would enable us to do the connections, build and change a switching logic in a simple way. So they created such a system based on a digital computer, and they called it a programmable logic controller. A programmable logic controller is basically an industrial computer system which is continuously monitoring input variables and making decisions according to the state of the input variables, state of the program, and output variables. The decisions are written to the output variables. PLCs has to be robust enough to work in rough environments with high temperature, humidity, vibrations, dust, toxic gases, and so on. What are the main building blocks of a programmable logic controller? Power supply provides necessary voltage, energy for operation. The CPU, the central processing unit, contains the processor and memory to execute the program. The input and output modules are the interfaces to field devices such as sensors, switches, valves, motor starters. Communication module allows PLCs to communicate data over industrial protocols. On this slide, we can see a more illustrative schematic picture of a PLC. Here we can see, apart from the input modules, output modules, power supply, and central processing unit, also a programming device, normally a personal computer, which is used for creating, editing, and maintaining a program, and that program can be downloaded or uploaded to the central processing unit via the communication module. Input devices are essential components of a PLC system, providing the necessary information for the PLC to make decision and control processes. The choice of input devices depends on the specific application and the type of information required. Output devices are the means by which a PLC interacts with the physical world. They allow the PLC to control machines, processes, and other systems. Some of the examples of output devices are valves, motor starters, horns and alarms, stack lights, control relays, pumps, printers, fans. PLC operation. In this slide, we will see the most important steps in PLC operation. After the startup, the init task is executed. This task prepares the PLC and the control system for operation by initializing variables, configuring settings, and performing startup routines. It runs only once at startup. Afterwards, the cyclic task is started. The cyclic task continuously executes the main control logics, reading inputs, processing data, and updating outputs in a loop. This is where the ongoing operation of the system is managed. Most of the operation time of a PLC will remain in this task. Before the shutdown, the exit task is executed. This task safely terminates operations, saves necessary data, and ensures that the system is left in a safe state upon shutdown. It runs once during the shutdown process. In the previous slide, we have said that the PLC will spend most of the time in the cyclic task. So let us have a look what exactly is happening in this task. One cycle is divided into 4 steps or scans. The first scan is the so-called input scan, where all the input variables are read into the memory. In the second scan, the CPU executes the program logic. In the third scan, the calculated output values which are stored in the memory are sent to the outputs. In the fourth scan, the housekeeping is done, communication, diagnostics, and so on. And again, after the 4 scans are over, we start with the first scan again, as defined by the cyclic execution. PLC programming languages. The EIC 611313 standard is a global standard that defines the programming languages and methods used for programmable logic controllers. This standard provides a common framework for PLC programming, making it easier for programmers to develop software. A POU is a fundamental building block of a IEC 611313 PLC program and represents a reusable unit of code that can be independently developed, tested, and maintained. According to the standard, there are 3 types of POUs. The first one is the program. This is the highest level program organization unit. It contains the main logic and calls other POUs. Then we have the function blocks. They encapsulate specific functionality, algorithm, maintain internal memory, allowing it to remember past states and values. They are useful for timers, counters, and so on. The functions perform a particular task and return a single value. They are stateless. Examples are mathematical operation, logical operations, data conversions, and so on. The standard defines 5 languages, divided into 2 main groups. The first group are the graphical programming languages. And the first representative of the graphical programming languages is the so-called ladder diagram. This was historically the first language used for PLC programming because it has evolved from relay logic control schemes. Because the first PLC programmers were the engineers who constructed relay control logic schemes. It is still commonly used today. The second important graphical programming language is the so-called function block diagram and also the sequential function chart, which is used for sequential processes. The second group are the textual languages. The first representative of the textual languages is the so-called structured text. This is today very commonly used programming language which is based on Pascal. And the second textual programming language is the instruction list. This is a language based on assembler. What are the benefits of PLCs? Flexible control. Unlike relay control schemes, programs can be changed on the fly without rewiring. This allows for quick modifications. Reliability. PLCs have far fewer points of failure compared to control schemes with thousands of relays. PLC system requires much less cabinet space than giant relay panels. Lower costs. Initial wiring costs are reduced in compared to logic control schemes. Software makes diagnosing issues and debugging of logics much easier. And PLC systems are scalable. Modular PLC systems can be easily expandable to handle more complex control processes. This video has received funding from the European Union's Erasmus Plus Cooperation Partnership in Vocational Education and Training Program. Thank you very much.